3.4a, exponential and logarithmic. All right, so let's go. 2 to the power of x is equal to 32. What's x? 5. This next one, I have natural log of x minus natural log of 3 is equal to 0. What's x? 3. This next one, I have 1/3 to the power of x is equal to 9. Now, how do I get a fraction that's lower than 1 equal to a number that's more than 1? What's going to happen? It's got to be negative. That's my childhood. It's got to flip. So, what's x to the power of? Negative 2. This next one, I have e to the power of x is equal to 7. All right. So last time when we had these as an inverse operation, the opposite of exponentiating something is what? Logging something. All right. So that's what we're going to do to both sides. So now I'm going to have natural log of e to the x is equal to natural log of 7. Math's an equal opportunity sport, so what you do to one side, you got to do the other. Now, what happens when I natural log and e to the x? The x comes out. All right, the x comes out, and then natural log of e is what? 1. So then I get x is equal to natural log of 7. All right. This next one, I have natural log of x is equal to a negative 3. Well, if I have an e to the x and I just natural logged it to get to x, well, now I have a natural log of x, so guess what I do here? I exponentiate it. I e it. All right? So now I'm going to e both sides. So then on my left side, an e to the natural log of x is just what? Just x. And then I'm left with e to the power of negative 3. All right? And for right now, I'm cool with it like that. All right, this next one, I have log base what? Whoa, I don't have a base. What's my base? 10. Log base 10 of x is equal to negative 1. Now, how do I solve a logarithm in this form? A to the c is equal to b. So my a is 10 to the power of negative 1 is equal to x. Well, what is 10 to the power of negative 1? 1/10. All right. This next one, I have log base 3 of x is equal to 4. So again, how do I solve a log? A to c is equal to b. So now I have 3 to the power of 4 is equal to x. So what does x equal? 81. Here are the strategies for solving exponential and logarithmic equations. And Courtney is going to read number 1.
0.05.
Hold on, buddy.
Rewrite the original equation in a form that allows the use of the one-to-one properties of exponential and logarithmic functions.
All right, so if they have the same base, we're going to use one-to-one property. Number 2, Angela.
Rewrite an exponential equation in logarithmic form and apply the inverse property of logarithmic functions.
All right, what's an inverse of a log? An exponentiating. All right. Number 3, Skipper.
Rewrite a logarithmic equation in exponential form and apply the inverse property of exponential functions.
All right, so it's in log form, what are we going to do? We're going to exponentiate. If it's in exponential form, what are we going to do? Log it. All right, so part A. I have e to the power of negative x squared is equal to e to the power of negative 3x minus 4. What property could I use? I could use the one-to-one property because they have the same basis. So let's do that. So now I end up with negative x squared is equal to negative 3x minus 4. Now, how do I start this process? What would I suggest you do? I add x squared over. So now it's set equal to what? 0. So now I have x squared minus 3x minus 4 is equal to 0. What are we going to do to quadratics? We're going to f it up. So what does it f up to? X minus 4 and x plus 1. So x is equal to 4 and x is equal to negative 1. Technically, we should back substitute to make sure that they work. All right, they do. They do work. All right, let's look at part B. I now have 3 times the power of 2 to the power of x is equal to 42. Order of operations says parentheses, exponents, multiply, divide, add, subtract, right? So when we're solving one of these, we need to get the exponential by itself. So we're going to use SADMEP. We're going backwards with our order of operations. So what's my first step here? Divide by 3. So now I have 2 to the power of x is equal to 14. So right now it's in what form? Exponential form. So what could I put it in? I could put it in log form. So now it would be log base what? Log base 2 of 14 is equal to x. And just like what we went over on our board points, what could I use now? Change of base. All right, so then I'd end up with what? Not log 2. Log 14 over log of 2. So then I type that into my handy dandy calculator. Beta what? 7.4. All right. Let's do this next one. I have e to the x plus 5 is equal to sissy. All right. So what do I need to do to start getting e to the x equal to a number? I subtract the 5. So now I end up having e to the x is equal to 55. Now, how do I get this x down? I log it. All right. I'm going to prefer doing a natural log. So if I natural log this thing, what happens to the x? It goes out front. Why does I say equal to 55? Natural log of 55. All right, so the x actually comes out front, and so now I have x natural log of e. So what happens when I have natural log of e? It goes to 1. So more often than not, I'm not going to show going from here to just x. All right, because that's what we know happens. So now I have x equal to natural log of 55. So now we type that into our handy dandy calculator. The other part. All right, what do we get? All right, fantastic. So now I have 2 times the quantity, 3 to the power of 2t minus 5, minus 4 is equal to 11. All right, so we got lots of steps going on here. What's going to be my first step? I add 4. All right, so when I add 4, now I end up having 2 times the quantity, 3 to the power of 2t minus 5 is equal to 15. Then what are we going to do? We're going to divide by 2. You want to call it 15 halves, or you want to call it 7.5? I didn't get a good response. What is 15 halves? All right, 15 halves. All right. All right. So now I have what form? Exponential. So what are we going to do to it? We're going to log it. All right. I could put it in log base 3 form, or I could just natural log it. And I'm going to natural log it just to show. All right. So when I natural log it, I have natural log of 3. But what happens to my 2t minus 5? It comes out front. All right. Make sure you make it a quantity. And then I have natural log of 15 halves, or 7.5 if you want to do it that way. Now, what's my relationship with 2t minus 5, the quantity of, and natural log 3? Multiplication. So what are we going to do? We're going to divide. All right. So now I end up having 2t minus 5 is equal to natural log of 15 halves over natural log of 3. All right, now what? Not yet. We're going to add 5. So we're going to add 5, and then what? Divide everything by 2. So now I have t is equal to natural log of 15 halves over natural log of 3 plus 5 all over 2. I would highly advise you put a parenthesis around that numerator. All right, very nice. Good in the hood? All right. This next one, I have e to the power of 2x minus 3e to the power of x plus 2 is equal to 0. I call these a special name. What do I call these? I call these a hidden quadratic. All right? They're not actually a quadratic, but they work as a quadratic. All right? So if you rewrite it, you could rewrite it as e to the power of x squared minus 3e to the power of x to the first power plus 2 is equal to 0. Honestly, guys, if you can factor x squared minus 3x plus 2, you could factor this one. All right. What does x squared minus 3x plus 2 factor to? X minus 2, x minus 1. All right. But instead of x, what are we going to put? An e to the x. So now I have e to the x minus 2 times e to the x minus 1. All right. They're what's said to be in quadratic form. All right. I just call them hidden quadratics. So now we're going to use the zero product property. So e to the x is going to equal what? 2. And then I get e to the x is equal to 1. Well, how do I solve an e to the x? What do I do to both sides? I natural log it. So now I end up having x is equal to natural log of 2, and x is equal to natural log of 1. Well, what is natural log of 2? We put that in our handy dandy calculator. What do we get? 0.6931. All right. And then what do we know natural log of 1 is? This one's one of those you should just know. 0. So I get x is equal to 0. The other one is natural log of e. What's natural log of e? 1. All right. You should know those two really, really well. All right. Technically, those are ordered pairs. Why do I say that they're technically ordered pairs? Now, it just says solve. But technically, it's an x-intercept. Why is it technically an x-intercept? Because y is equal to 0, exactly. All right. So graphically speaking, this is what's happening. You got this funky curve, and you're technically solving for x-intercepts. All right. That's really what's going on there. All right. It's not technically a quadratic, but it acts as one. All right. There you go. There's your flow map.